In this episode, I wanted to talk about the difference between hard and symbolic links. We will look at why links are useful, the pros and cons of hard versus symbolic links. Then we'll take a look under the hood at inodes and file system metadata to see how links actually work. Links in general serve the very useful function of acting as an alias or shortcut for a particular file or directory. We are all familiar with creating desktop shortcuts. Well, symbolic links are very similar to this. Basically, we create a symbolic link that acts as a pointer to the real file, which in turn points to the data on the disk. As you can see in the diagram here, we have created a Firefox symbolic link from our desktop which points to the user bin Firefox file. Personally, I find symbolic links intuitive and easy to understand. So what about hard links? Well, hard links are a little different in that instead of creating a file which acts as a pointer to the real file, we're essentially giving that file a second name. As you can see in the diagram here, we created a Firefox hard link from our desktop, but instead of pointing to the user bin Firefox file using a symbolic link, we actually just gave the Firefox file on our desktop a second name, and that second name points to the data on disk. A long time ago, when I was first learning about Linux, this concept went against my mental model of how files worked. I assumed files could only have one name, but with hard links, that idea goes right out the window because files can actually have multiple names. Let's look at some real-life examples. So I've created a directory called project, and in that directory I have three files, foo, bar, and baz. To create links between files, we can use the ln command. Let's take a quick peek at the man page for the ln command. So as you can see, the ln command makes links between files. Then down here it says the ln command makes hard links by default. And if we want to create symbolic links, we need to use a specific option. Okay, so let's create a symbolic link first, which is often just referred to as a symlink. So we're going to create a symlink to this foo file. Then let's run ln-s, then the syntax is target, then the new link name. So let's just type foo as the target, and then foo-symlink as the new name. Running ls again, you can see that our new link was created, and then it gives this nice visual output indicating that this file is actually a link. You can also see the letter L indicated over here. This denotes that the file is actually a symbolic link. Let's run the stat command on the foo file, and you can see here that it says it's a regular file. Then let's do the same for the foo symbolic link, and you'll notice here that it says this is actually a symbolic link. So this kind of goes back to the diagram from earlier about symbolic links just being pointers to real files. Okay, so what about hard links? Well, let's look at the same project directory again with the same files. Let's create a hard link to the foo file. Since the ln command creates hard links by default, let's just run ln, the target, in this case foo, and the new file name. Let's just call it foo-hardlink. Then let's run ls again to look at the output. One thing you'll notice right away is that it's not easy to tell the foo and foo-hardlink files are linked in some way, or that they are in fact pointing at the same blocks on disk. With symbolic links, at least you get this L indicator, and that you can visually see that this is a symbolic link. There is one way to tell though. You can see here that there's this number 2, where before there was just a 1. So let's run the stat commands again against the foo and the new foo hard link. You will now notice that the link count says 2, and the inode numbers match. This indicates that the two files are in fact pointing to the same blocks on disk. Essentially, this means that this block of disk has two names associated with it. To really understand what is happening here, we need to know a little about inodes and how directory structures actually work. You can read all about inodes, sometimes called index nodes, on the Wikipedia page. I've provided these Wikipedia page links in the episode notes below. But to give you a simplified idea of how directory structures and inodes actually work, let's take a look at some diagrams. Okay, you can think of directory structures kind of as a database, a very simple database with two columns. The first column will be the file name. As you can see here are foo, bar, and baz files. And then in the second column you'll see inode numbers. These inode numbers actually point to a second database which hold metadata about each file. This metadata includes things like the file size, its type, the device that it's stored on, the UID, GID, along with permissions, timestamps, and the link count. And then in the last thing here, you'll see pointers to disk blocks. This actually points to physical blocks on the disk where a file is stored. Just to reiterate, so there's actually a chain happening here. We have our directory listing, which stores the files and inode numbers. These inode numbers point to another metadata base, storing information about each file. The inode actually points to blocks on the disk. I should note that the blocks on the disk diagram is very simplified. It's actually a lot more complex. But if you want to read about it, check out the inode pointer structure wiki page listed in the episode notes below. Okay, so now that you know about inodes, and that each file actually maps to an inode, and then each inode actually maps to blocks on the disk, let's take a look at the differences between hard and symbolic links again. Symbolic links actually work like this. We create a symbolic link file, which creates a new inode entry. This inode 456 points to the physical path user bin Firefox, and the user bin Firefox points to its own inode 123, and that inode eventually points to the blocks on disk. Hard links are much different in that there is no additional inode. All that happened was that the directory listing database was updated with our new file name, using the same inode entry as the file we're linking to. For this reason, you cannot create hard links outside a specific file system, for the simple reason that we're actually linking to the file contents, and the file contents won't exist on another file system. This is where symbolic links actually come in really handy. Let's jump back to the foo, bar, and baz files for a second. In this example, the directory listing will look something like this. We have the foo and foo hardlink files, which actually have the exact same inode number, whereas the foo symlink file actually has a different inode number. We can verify this by jumping over to the command prompt. Let's run ls-li. The I option actually shows us the inode numbers. You can see the inode numbers listed in the left-hand column here. You will also notice that the foo and foo hardlink files have the same inode number, which actually means they're pointing to the same blocks on the disk. Then down here we have the foo symlink file, which has its own inode number, and that inode acts as a pointer to the foo file. Hopefully this is not too confusing. I just wanted to show you the differences and actually what was happening under the hood, so that you could understand what was going on. I do not usually create hard links, because I do not generally expect a file to have multiple names, and if it does, I expect it to be a symlink. You might be asking yourself, when would I use a symbolic link over a hard link? Well, 99% of the time I use symlinks. In fact, I can probably count the number of times on one hand that I've used hard links. Personally, I just find symlinks more intuitive. And in a shared environment with multiple people using the same system, I'd like to err on the side of clarity. So my suggestion would be to use symlinks unless you have a good reason not to. Just to recap, let's look at a summary of the differences between symbolic links and hard links. So with symbolic links, I find them easy to understand because they stand out and it's easy to see what's going on. Symlinks work for files and directories, and symlinks also work across file systems. On the other hand, I find hard links hard to recognize in that you have to do additional digging to see what's actually happening. Hard links only work for files and not directories. I guess theoretically it's possible, but it hasn't been implemented. The reason is that you could easily create nested directories, which would confuse the system and potentially lead to a denial of service condition. Hard links don't work outside the file system, because when you create a hard link, you're actually linking to the blocks within the file system, and those blocks can exist outside the file system. Hard links see a benefit over symbolic links because there's no additional inode overhead. You don't have to hit the disk again to follow a symbolic link. So if you find yourself needing to create a link, hopefully this episode will clear up some of the differences between hard and symbolic links and help you choose the correct type. Alright, that concludes this episode. Thanks for watching. If you would like to get notified about future episodes, please subscribe to my mailing list. You can do this by going to the Get Notified link in the header and entering your email address. Have questions, comments, or concerns about this episode? What about episode ideas? I'd love to hear your feedback, either good or bad. Shoot me an email, justin@sysadmincasts.com.